طيب, Bismillah ar-Rahim. So we'll continue talking about Ethernet, chapter 9. And we started talking about multi-access control on Ethernet. And we discussed carrier sense multiple access with collision detection. And the protocol, this is the procedural steps for the Cmpe CD protocol. So basically, each node. So this algorithm works independently and in a distributed way on all the nodes at the same time. So each node is going to perform all these steps independently from all the others. And that's why we cannot eliminate collision. So the only way to eliminate collision is by having a centralized control or by having a predefined division or predefined slots for each one to use, and nobody else uses that except only one node, like TDMA and FDMA and so on. And we said that this is not efficient because you can assign some resources to a node and the node does not use that, so you waste all these resources. So here, we're trying to utilize the resources as much as possible. So each node is going to perform this. First, each node listens to the network's shared medium. The sensing here happens continuously, and what happens is that each node can measure the power level on the line. If this power level is above a certain threshold, then this means that there is somebody else using the line. If the power level is close to 0, this means that nobody is using the line, so the line is available, I can send. Of course, you have to sense for a specific duration of time. If no transmission is happening, no transmission is sensed by the power level, then multiple access allows any node on the line to send. So each node will then decide whether it sends right away or it doesn't have data to send, so it doesn't do anything. So each node will try independently to make that decision whether it wants to send or not. If two PCs send at the same time because they have decided that the line is available, both of them took the decision that the line is available and they try to send at the same time. So in that case, two or more, of course. So in that case, the collision will happen. The PCs sense the collision. So that's interesting because while two nodes are colliding together on the line, other nodes may try to sense. So these nodes will find the power level doubled on the line, almost double. So if we assume that the transmission power is P, then any node that will try to send during the collision time will find that the power level on the line is almost 2p, almost 2p. So if the power level is almost 2p, then there might be a collision. So in that case, the node will decide that there is a collision. So now the situation of collision is a little bit interesting. So we have this shared line, and we have multiple nodes are trying to access this line. So if this node tries to send, so this is the time. This is the time line, and this is the distance or the spatial situation between all these nodes. So if this node tries to send, okay, so it will send, and the transmission takes some time, right? to reach each node. So this node will listen to the signal at this time. This node will listen to the signal at this time, and so on, right? Assuming now that this node tries to send at the same time. This node will try to send maybe somewhere here. This node decided to send. At this time here, this node does not see any signal, right? So for this node, the line is available. So it tries to send, and the collision happens somewhere here. Collision happen here means that this is the first point of collision. Of course, the collision means that both signals are not usable anymore. Okay, but this is an interesting situation because that tells you that so any node on this shared line that's trying to sense, it may detect the collision first. Potentially, which one is the closest to sense that this is a collision? The one that's yes, the one that's this one basically. So if we just mark it, so they basically, where is that? Yeah, this one. Right, so if this node tries to sense, potentially this node is the first one that will detect the collision. Okay, which currently this node is not part of the transmission or the reception in any way, but potentially this is the one that if it's sensing the line, then it will detect the collision as the first node. Okay. So going back, so the PCs sense the collision by being unable to deliver the entire frame. So you have two cases now of detecting the collision. One is explicit and one is implicit. Okay, the explicit one is mentioned here. The node that will detect the collision for the first time, it may. Okay, and it may is underlined because this node detects the collision only if it's sensing. If it's not sensing, then it may not detect the collision. Okay, so assuming that it senses, it will detect the collision, in which case it will send a jamming signal. It will send a jamming signal. It will send this signal across the line. Everybody will listen to it. Okay, so I'll come back to this jamming signal to see how we can send it. But this is the explicit one. The implicit one is if I don't receive any jamming signal, if no node is sensing and no node detects the collision for the first time, then there is another implicit way of detecting the collision indirectly by not receiving the acknowledgement. So so each node, so this node will send to one receiving node. This receiving node may be this one, maybe this one, maybe this one, any node. Okay. So the receiving node will not be able to decode the signal because the collision has happened. And in that case, it will not send back the acknowledgement. So this is the implicit way of detecting that there was a collision. Okay? So we have two ways, one implicit and one explicit. So going back to the jamming signal. So, well, how can we send a jamming signal to inform everyone while there is a collision? Remember that, well, collision signal is not, well, it's not recognizable. Right? So you might ask yourself, I mean, how can I send a jamming signal while the shared line is not usable? Well, the shared line is not usable on the frequency range that's used for the transmission.
There's another.
So what we could do is that we can simply say that during the baseband, because Ethernet uses baseband, it does not modulate, it does not send across like using any carrier signal like the case of Wi-Fi. Here it sends using a baseband. That's why it's called a 10 base T or 100 base T. We talked about that. So this is the frequency range. This is F, right? So this is the frequency range that all nodes use for transmission. So the collision happens here. Okay? If one node detects the collision, it sends a jamming signal. This jamming signal is sent across or using another frequency range. Okay? It's called out of band signal. Out of band signal, yani out of the bandwidth of the original transmission bandwidth. Okay? So that's the way for us to send a jamming signal. But in case we don't receive the jamming signal, then we have to wait until the timeout happens and we don't receive an acknowledgement, in which case we also conclude that there must have been some collision. Okay? Of course, the jamming signal is preferable in that case because I don't have to wait until the timeout. If one node detects the collision and informs everyone, so everyone will be informed early. But if they are not informed, then they have to wait until the timeout expires, which will incur some delay. But I mean, this is the only way because the jamming signal was not sent. Okay, so any question? Okay, so the other interesting thing here is, okay, so what will happen when the nodes are informed that there is a collision? So what can they do? Okay, so two nodes are trying to send and they detect that there was a collision. So now, what do we do? Okay, so they can use either a priority-based scheme or a random back-off scheme. Priority-based scheme here creates some kind of discrimination between the nodes. So we can use this collision situation to provide some priorities for some nodes. For example, if we have some nodes on this shared medium that we want to give higher priority than others, then this node will back off. Back off means that it will wait for the collision to be cleared from the line, and then they have to wait for a specific delay, okay? And then try again to sense and send. Okay? So this delay, it should be different from one node to another. Otherwise, if this delay is the same, it defeats the purpose, right? So if the two nodes wait for the same delay and then try again, then we didn't do anything. So we have to make this delay different. Okay? So we agree on that. So this delay can be different using two different ways. The first one is using priority. If we know that one node has higher priority than the others, so this node has to wait for a shorter or less time. Bravo. This node will wait for a shorter time, because if this node tries to access the line before the other one, it will gain access first and it will start to send. Okay? So this is the priority-based scheme. The random-based scheme says that, okay, we don't want to make any discrimination between the nodes. On the contrary, we want to be as fair as possible. So this random back-off scheme will say, okay, so let each node, because this is distributed, let each node generate a random number and wait for a time equal to this random number. Okay? When we generate a random number, there is a possibility that this random number will be the same, but this possibility is way low. Okay? So chances are, if two nodes generate random number, the random number will be different. But what's the advantage of using random number? Well, the advantage of using random numbers is that if nodes generate high number at this point, it will generate low number at another point. Because the probability of random number means that the probability of selecting a specific number within that range is the same. It's the same. It's called uniform distribution. Yeah. So the probability of generating any number is the same. So if I generate a low number now, chances are I will generate a high number later. If I generate a high number now, I will generate a low number later, which achieves this fairness. Yes. So if two nodes generate two random numbers, one node will generate a random number less than the other. If the same two nodes collide again in the future, chances are they will be reversed. This is the advantage of using random back-off scheme. Analyzing this on MATLAB or experimentally, you can easily find that this random back-off achieves complete fairness between the nodes. Okay, complete fairness. It's extremely fair. As long as generating this random number has a uniform distribution. Uniform distribution means that the probability of generating any number is the same. Yani the probability of generating a specific number is 1 over m, 1 over n, where n is the number of the digits or possible numbers that we generate. Okay? Type. So until here, it's fine. Okay, so random back-off will help us achieve that fairness. The last step here is that if collision continues to occur, well, first, what does that mean? Intuitively, what does that mean? Well, this means that I try to send now and I collide with a node. And then both of us will back off. And then one of us will try to access the line. It collides with another node because it cannot happen that we collide with the same node. The probability is way low. We collide with another node. Okay? And then both of us will back off, we'll try to access the line. One of us will access the line, it will collide with another node. What does this mean? Intuitively, what does this mean? Well, this means that the load on the line is just huge, right? Is increasing, is more. Okay, so what do we do in that case? Well, what we will have to do in that case is that when we try to generate a random number, we should try to generate a random number with very high ranges to allow us to wait for a longer time, which means that potentially what you're trying to do is that you slow down these nodes because the line is too busy.
Yes, so you slow it.
It's like there is a traffic jam on the roundabout. Okay, well, we'll have to wait. We cannot just bombard the line because the collision will keep happening. So this means that there is a jamming load on the line, so we have to wait. How can we do that and at the same time perform the random back off? Just by increasing the range we use to generate the random back off. Because there is now higher possibility that some nodes will generate a delay which is very high. Okay, and in that case, the nodes will potentially slow down. Okay, so they do that using exponential random backoff. So if now we have, let's say like we have a duration of t. Okay, if a collision happens, then we generate a random number between 1 and 2. So potentially one of us will generate 1, the other one will generate 2, which means that I will wait for t, you will wait for 2t. Okay, so I will gain the access to the medium first. When I generate, or when I try to access the line, another collision happens. The 2 becomes 4. So all of a sudden now we have a window of 40 that we generate the random number between this range. So if you can generate a random number of 4, which means you have to wait for 40. If collision happens again, then the 4 becomes 8. And the 8 becomes 16 and so on. Okay? Okay, so we talked about some details as part of this protocol, because it's very common protocol, and it's complicated. It's not as easy as we discussed before. So using hubs, the hub is simply, as we said before, it's a multi-port repeater, in the sense that it does not work in the digital domain at all. It does not convert the signals into digital. It just deals with analog signals. So you can think of it this way. It does not check for any field inside the frame. It doesn't do that. All it does is that if we send a signal on a specific port, the hub will take the same signal in analog domain. It will not convert it. And then it will replicate it on all other ports except the one it came from. That's it. So, assuming that you have 2 hubs connected in serial like this, which is possible, like if you have number of nodes more than the number of hubs on one hub, in that case you can connect 2 hubs as chain. They call it daisy chain. And in that case, you can almost double the number of ports. So in that case, the signal that goes on one line, it will have to be replicated on all other ports. So at one point in time, when we send on one port, this signal will be replicated on all other ports, on all hubs connected in serial. Which creates this logical topology of shared medium, as we talked about before, which necessitates the fact that we have to use a decision address. So if this node wants to send to this node, for example, this node has to put the destination address, so that the signal will have to be replicated on all the ports. So in that case, each node will wait. Yeah, so this explains the fact that it's a multi-port repeater, and in that case, the signal will be propagated across all the nodes. So this node will say, I'm not the one targeted by this frame based on the destination address, and all the nodes will say that except that the one that it's destined for. And the disadvantage of the hub here is that because the hub propagates or replicates the signal on all the ports, it forces all nodes on the shared medium to have to decode, okay? Because the hub does not decode. So the disadvantage of you not decoding the signal is the fact that all the nodes will have to decode the signal. Okay? So all the nodes will have to convert the signal into the digital domain, and it has to check the destination address and then decide that this address is not distant to me. So in that case, I will discard it. I will ignore it. I will not send it up to the network layer. So that's even though it's cheap on the hub side, because the hub does not have to be sophisticated in terms of converting the signal into digital domain and processing the frame in any way. And that was the motivation for the fact that the hub is very simple and very trivial device. But the side to this is the fact that all the nodes have to every time check the frame, which is expensive. So the disadvantage is represented using the concept of collision domain. A collision domain, so the hub creates the concept of collision domain, which means that if any two nodes connected to any of these hubs that are serially connected, if any of these two nodes send at the same time, the collision will happen. In which case, there's one collision domain between all these nodes together. We call it a collision domain. This means that any two nodes in that domain will collide together. Okay? So this means that all this topology constitutes or represents one collision domain. Okay? So if this node sends to node 3333, then this node will likely reply with an analog or acknowledgement frame. So what happens when two hosts on the same hub, or when multiple hubs are connected, transmit at the same time, the collision will happen. This is what we have described before. So now we would like to explain the concept of collision domain. If we have the hubs connected like this, so these two hubs are connected in serial, and then you have multiple hubs connected using this topology. First of all, I can ask you, what is the logical topology of this?
It's the same like the one hub and the PCs.
So all these hubs,
Yes. One line. One node.
all these hubs can be theoretically represented using one hub, which means that this is potentially one shared line like this.
Yes, one.
That's it. So how many collision domains do we have here? Only one, right? So all this is a collision domain. See, that's easy. So we have single collision domain, which means that within this domain, any two nodes might collide if they try to send together. Okay. Type. So what is and what would be the duplex settings? Well, this is half duplex in that case, because if one node tries to send and another node tries to receive, the collision will also happen, which means that you should have only one node sending, okay, and all the other nodes will have to be receiving in that case, which means it's half duplex. It doesn't work that you can send on, even another node tries to send to the same node, the collision will also happen. Okay? So the hub, by default, creates what we call a half duplex port. You cannot send and receive on the same port. Okay? So to understand this better, we will talk about a switch. So a switch is different from the hub in the sense that the switch is intelligent, and it receives any node on any port. It will have to take the signal, convert it into digital, put it in the buffer, process the address in this frame, and then it sends it only on the port that it knows that the destination is connected to. Okay? So in that case, if you send a signal from here, from anywhere, from any node. If you send a signal from here, and from here, will the collision happen? No. So there is no collision in that case, because both signals will have to be converted into digital, and then they will be processed one at a time. Okay? So the collision in that case will not happen. Okay? So where are the collision domains in that case? How many collision domains do we have? 6 collision domains. So for each hub, we have a collision domain, and each domain is separate from the other domain. So we have 3 here and 3 here. Okay? And they are separate from each other. Well, another thing you need to understand about switch is that if this node here and this node try to send and receive to each other, the switch will store each frame independently, and then it will perform the transmission normally, which means that the collision will not happen. So if this node tries to send to this node, and this node tries to send to this node, at the same time concurrently, then the collision will still not happen. Okay? In which case, the switch creates some kind of a full duplex connection or a full duplex port. So the switch can send and receive on the same port with no problem, because it always has to take the signal, convert it into digital domain, and put it in the buffer, and then it will process each one separately. So they will never collide. So in that case, the switch when it connects to another hub, then this is half duplex port by connection to the hub. So this connection is half duplex. However, between 2 switches, it's full duplex because you can send and receive at the same time. Between a switch and a router, it's also full duplex because the router is a switch. In addition to that, it's a router, which means that it routes packets. So it creates a full duplex port. So in that case, we have how many half duplex ports? So you can count 1, 2, 3, مثلا, 4, 5, 6, 7, 8, 9, and so on. So you can count it this way. Okay?
So for single hub, 2 PCs, they cannot send together, right?
No.
But one can send and the other receive on the same hub.
On the same hub here?
Yes.
On the same hub?
The other can.
All the others have to receive. They have to receive, otherwise the collision will happen.
Yes.
All the others have to be receivers.
In this case, it's on one receiver.
There is only one receiver, but all of them have to be in the receiving state. Otherwise, if anyone tries to send, the collision will happen. That's why we have a half duplex port in that case. So by default, any port that's connected to a hub is by default a half duplex port. Okay. Okay, so let's see. So how many? So this is a fairly combined and complicated topology. So how many collision domains do we have here? We have 2 because we have 2 hubs. So anything that's connected to the hub forms a collision domain. Switch does not form any collision domain because if 2 nodes connected to a switch and they try to send at the same time, the collision will not happen. So these 2 nodes, because they are connected to a switch, they will not collide with each other. These 2 nodes, they will not collide to each other. These 2 nodes, they will not collide, and so on. So only the 2 hubs, only these. Other than that, we have no collision domains. Okay? So in that case, we have 2 collision domains only. So how about ports?
How many? You mean the full duplex ones?
How many half duplex ones?
2, 6.
1, 2, 3, 4, 5, 6. Right? And of course, this one is half duplex, this one is half duplex.
But you
Right?
counted once. يعني بنعد مرة واحدة يا فوق يا تحت. You don't count it twice.
Yes, you count once.
For that.
Okay, so these are the half duplex ones. The full duplex ones are the remaining ones. Okay, all the other ones are full duplex because they are not connected to a hub. Okay, any questions? Okay, so similar to what we have done for the IP address, we have defined in the IP address classes 1 and A and B and C, and we said that class D is used for multicast. Actually, the physical address, even though the physical address is not as structured as IP, but the physical address as well can use multicast. And multicast here means that you can send on the shared line, you can send to 2 nodes at the same time or 3 nodes at the same time. Not broadcast, because broadcast is easy, it's all Fs, and all the nodes will have to consume that frame. But multicast here, you send to a specific group of nodes, not necessarily all of them. So it's not all Fs. However, they use F on one part and non-F digits on other parts to indicate that this is not a broadcast address, it's a multicast address. And based on the part that's not F, you can create multiple subgroups on the shared line. There is a unicast address, of course, which we talked about before, which is divided into 2 parts. حد فاكر 2 parts سمعي؟ Yeah, so organizational unique identifier and the identifier for the device that's manufactured by a specific vendor. So that's the unicast address. Broadcast address is all Fs, so that's easy. And multicast address is all Fs, and then another part is non-all Fs, which indicates that this is a multicast. And by changing this part, you can create multiple subgroups between the nodes. Okay. Okay, so we'll stop here.